Okay, a little warm-up activity for you to think about before we really launch into number talks. So the key part of number talks is that you work without pen or paper or any calculator. So we're really just focusing a little bit on our mental strategies. So we'd like you to have a think about which one of those two is larger. Okay, if you do have a response, then feel free. For this, we're just going to ask you to contribute in the chat box. So feel free to type your solution in the chat box. And while you do, then if you may also want to chat your reason. Okay, thank you. We're getting quite a few contributions there. And those of you who have seen us present before, we always like to start, just as we role model our classes, with a warm-up. We're not going to go into too much detail with this one. We're going to leave this one with you as we proceed with number talks, and then raise some of these issues later on, because we will look at a couple of fractions as well. So what are number talks? So basically they're a pedagogical strategy that was first started by Ruth Parker and Kathy Richardson out at Stanford University in the early 1990s. Since then, Kathy Humphries has been instrumental in extending number talks to secondary level. So we know that a number of our primary colleges have been using it for a while, but it has been extended to secondary, and they also now use it with a lot of the teacher education students there. You'll find that through number talks in a short span of time, number talks can assist students to develop their mental skills. They teach number sense, and also we're engaging in some open maths where we're sharing ideas and strategies and making it more open-ended. A lot of the work on number talks has also been, you'll also find a lot of it on the YouTube clip, from Joe Bowler and team again out at Stanford University. Okay, so what's the process we normally go through with number talk? Basically, the teacher will write the problem on the board, or if we're in the virtual platform, as is this, it might be on the PowerPoint. The key strategy is that when we ask students, and the way we're going to present this for you today, the way Daniela and I are presenting this, is we're role modelling it as if you were doing it in a class. So therefore, we're going to be asking for your participation in that sort of setup as well. So basically, the key direction is without pen or paper, we ask you to solve the problem mentally. At the conclusion of that, we ask for students to share solutions. and share strategies. At that stage, it's really important not to comment on any of the solutions, even if any of the students do bring up the wrong solution. You then select, and again, another strategy with number talks is rather than the hand, again, because of all the coming out of that group, as we said, from Stanford with Joe Bowler and the whole move, I suppose, with the positive mindsets, is not to sort of aim for the hands up, but to use the thumb in front of your body in that sense. And or if we're using a virtual platform, then a thumbs up on the chat box or something if you have a solution and at that stage wish to share. So we're going to probably be asking you to share your solution in the chat box, and then as we see a solution, we may ask for a volunteer to explain their reasoning, and at that stage it's brings up that discussion amongst the class. So it'll be the teacher then guiding doing a diagrammatic representation of what the student has said, and then asking for the next student. So again, it's just talking through. The next student will then present theirs, and it's the same, the talking through. And it's really just that conversation that then, and that discussion amongst the whole class that then brings up and makes students think that maybe the way I did it was not correct. So there's no, we make it as non-confronting as possible. Okay, so the first one where, and we do also have a couple of papers that we'll share with you at the end of this. So there's some information from Joe Bowler, and also Dan Finkel through Maths for Love has got a paper on all the little tips and so forth for running these. Okay, so without using pen and paper and without using any traditional algorithm, we want you to work out the following problem mentally. And initially, we're going to ask you to type your solution, name and solution in the chat box. So there's the first one. Okay, we've got some solutions, but we'd like, of those people with solutions, we'd like to, if I select, or if someone would like to volunteer to give us their method now. So I'm going to stop sharing my screen, hand over to Daniela. And,
hello, everyone.
Okay, I think the first solution came from Anna Watson. Anna, are you happy to share how you did the problem? And we'd like you to unmute yourself. Yep.
Yeah, I'm going to say that. Thanks, Helen.
Anna, are you right to go through how you came up with your solution, please?
If anyone else would like to have a go, please unmute your microphone and just share how you reached your answers. Most of you got 152, which we can see. That's promising, but we'd just like to know how you obtained that.
It's Caroline. Daniela, can you hear me?
Oh, hi,
yeah,
Caroline.
thank you, Caroline.
Hi. So I just did 2 times 8 is 16, times 10 is 160, and then minus 8 is 152.
Oh, wait, hold your horses. So 2 times 8 is 16. So where's the 2 times 8 come from?
I just rounded 19 up to 20.
Oh, I see. So you said
right.
you didn't like the number 19, so you like 20
Yeah.
times 8. Okay,
Yeah,
so you did 20 times 8, then you did 2 times 8 is 16, and then 10 times that is 160,
Yeah.
and then, sorry, what did you do after that?
And then I just subtracted 8.
Subtracted 8, so it's 150.
I've been hanging out with grade 5s, and that's how they do it.
But it's still got the love it. Okay, else has unmuted themselves. Does someone else want to have a go at contributing how they solve this? in a different way?
I'm happy to give it a go.
Okay, who's talking?
Sorry, Tamara's talking.
Tamara, nice to hear from you. Okay, Tamara, you're in green. All right, let's go. What was your solution?
What I did was I split up the 19 into 10 and 9. So I did 10 times 8 first, which is the 80. And then I did the remaining 9 times 8 for the 72. And then I added up those two answers together. Yep.
Nice. Okay, great. Thanks, Tamara. Okay, you can mute yourself now. And if anyone else has a different way, so different to Caroline and Tamara's, we'd love to hear it. No?
I'll go. I just doubled and then doubled and then doubled.
Oh, you doubled and doubled. So who are you, first of all? Sorry.
I'm Lauren. I'm Lauren. I typed it in the chat already, but seeing as
Lauren. Okay, so you use the strategy that 8 times something, when you multiply by 8, you double, then double again.
Yeah.
So you basically doubled 19, then doubled it again, and then doubled it again. Is that right?
Yeah.
So what's 19 times 2? So what did you get there?
I actually started with 20 times 2 and then took away 2 to get my first double. And then, yeah, like...
Okay, so what did you do?
38 more easily. I wrote it in here. I did to double 19. Well, I doubled 20, then took 2, and that gave me 38.
Right. Okay. Yep.
And then 38 was a bit easier to double.
Okay.
Traditionally, doubled the 10s, doubled the 1s.
So what did you get?
Renamed to get to 76.
Yep.
And then doubled it again to get to 152.
Lovely. Thank you, Lauren. Okay, does anyone have a different strategy altogether? Oh, no? Okay. So in that case, what I want to do now is have a look at these 3 methods and represent them visually. So we've got Caroline's method. So Caroline said that she didn't like the number 19 that much. So she instead rounded 19 up to 20. So what I'm going to do is I'm going to draw Caroline's methods here. So the original problem, if you like, if I draw it as an area model, was 19 times 8. What Caroline did is said, okay, I don't like 19. I'm going to make that 20 times 8. Oops, that's a 20, by the way. And so that the answer to that, that area, the whole total area here, and I'm not very good at using this software, so I'm a bit messy with it, but you'll forgive me, is 160. And then you had to subtract the bit that you added on top, Caroline. So then you said that was just 1 times 8, which is 8. So 160 minus 8, which is 152. Thank you. All right, so then let's have a look at this second person. Was it Tamara? I think it was Tamara from memory. I'm just having trouble scrolling across, but I do think it was Tamara's method. So, okay, so let's have a look. Tamara said, not a fan of 19 as well, but I do like the fact that 19 can be broken up into 2 nicer numbers, a 10 and a 9. And then I could solve that area, which is 80, that area, which is 72, and then I can add them up to make 152. Lovely. And then Lauren, finally, this one's going to be a bit harder to draw, but how I would represent the double strategy best, and I'm not going to even attempt to draw it, I don't think at the moment, is, let's give it a go. Why not? Is, let's say, now ideally I think I would draw this as an array rather than an area, but 19 by 2, area here is 38. Now we have to double that, so doubling that, and then which the 2 together would be 76, and then I have to double that again. So I've doubled, I've doubled 19 to get to 38. I've doubled 38 to get to 76, and I've doubled 76 to get to that full area here, which is 152. Sorry, a bit messy, but hopefully that makes sense visually. I would probably do it in an array for the double, double, double. All right, thank you. And now what I want to do is move on to the next number talk. So we've had a go at 19 times 8. Now again, without pen or paper, I want you to have a go at this one, 12 times 18. A little bit trickier, but I think still doable. So just in your head, we'll give you a few minutes. Please share your answers in the chat box, and then we'll have a few people contributing again to the discussion. Some people are really speedy. They've already got it.
Just to make it easier, so we're not feeling like we're picking on you, if you're happy to share, just type your name in the chat box and say happy to share, and then we won't feel like we're picking on you.
Okay, so we've got, I think Hong, you were the first to say, oh wait, Michelle, you're first. Sorry. Michelle, your turn first to share your strategy, please.
Hi, how you going?
Good, thanks. How are you?
Good, thank you. So what I did is I split up 18 into 10 and 8. So 10 times 12 plus 8 times 12,
So
and then added them together.
you said 18 was 10 plus 8. So you did 12 times 10, which is 120, and 12 times 8, which is 96. And then you added them together.
Yep.
All right. And what's that? 216?
Yep.
Great. Someone else? Hong.
Hi. I looked at the 12 and I broke that up to 4 and 3, and then I don't know why, I just looked at that, and then I did 18 times 3, and then I just multiplied my answer by 4, because I thought of 4, like I could double
And double? Yeah.
Yeah, double and double again.
So what you did was you broke up the 12 into a 4 and a 3, and you multiplied
Four times 3.
Oh, sorry, 4 times 3. Yep. Sorry. Yep.
I should say I factored the 4. That's what
you
I did.
factored the 4. That's right.
4,
Sorry.
yeah,
Yep.
sorry.
So, oh, yeah, that makes more sense. I was like, what's going on? 4 times 3 times 18. So you did that, and then you said, I'm going to do this part first. Is that right?
Yeah.
And then you did that. How did you do that part in your head?
Yeah, I did that in my head. Yeah. Yep. I got 54, and then I doubled.
But how did you do that in your head? Because no one knows off of their head that 18 times 3 is 54.
Oh, okay. Then I would have, I broke it up to 10 threes and 8 threes, or I could have done, probably that would have been the quickest way, 10 3 and 8 3, and add it and sum it together.
Okay, so you did that. All right, so then you did 4 times, we've got here in the brackets, we've got 30 plus 24, which is 54. So you did that. Yeah. And then when you got to this stage, you said 4 times something is double and double again. That's
so I did 54. Yeah, I doubled 54, and then I doubled it again.
All right, so you did 50, double. So you did 108, and then doubled that again, and then you did 216.
Yeah.
Brilliant. Thank you, Hong.
That's a long way, isn't it?
Look, it might sound longer, or it might look longer when I've written it up, but in your head, it probably went a lot quicker than that. And it doesn't matter how long it takes, as long, you're accurate, and your method is wonderful. It works. So there's nothing wrong with it. It's perfect. And it's all about,
Okay,
this strategy is all about really just sharing lots of different ways that people have mentally solved these problems. And I think exposing students to as many possible solutions is really, really powerful. So thanks for that.
I think we've also got Anna Watson, who says she's happy to share. I'm not sure whether, Anna, you had a different method. So I've got Anna, Michelle's shared. We've got Caroline.
Yep. Can you hear me?
Yep.
Yeah, sorry. Computer problems before. Yeah, just did 10 times 18 plus 2 times 18.
Okay, so you broke up the 12 like that.
Yeah, that's right. Yeah, that's right.
Sure.
Try and use the largest number to multiply by 10 as a boost.
Okay, so you look for, you'll go, okay, 18 is my largest number. I can split up my smaller number into a 10 and something else to multiply. Yeah, I get it. Great strategy. Thank you.
Yeah.
Thanks, Anna. All right, so I think we'll just leave it at 3 for now. Otherwise, I'll be drawing rectangles all day. So let's go through Michelle's strategy and how that might look visually. So what Michelle did was split up the 18. So if we look at that as an area model, let's say 12 is there, 18's there, and 18 can be drawn as 10 and an 8 in terms of the lengths, 10 plus 8. And then this area here is 120, 10 by 12, and this area here is 96, and then all together, that's 216. Great. I'm just going to go to Anna's first because I'm a bit intimidated about drawing the other one, but let's have a look at Anna's first. So same rectangle. We've got 18 at the top, but what Anna did was she split up the 12, so that's fine as well. Instead of splitting up the 18, Anna said that 12 is 10 by 2, split it up that way. So that's 118 and that's 36. So together that's 216. Now let's go back to Hong's method. Okay. Righty-o, how do I draw this? If anyone would like to help me out, just come to my rescue. Yep.
Could you split up so it's splitting up the 12 first. So if you do an initial breakup of 4 and 3, and then the 18 also gets split, so you're going to have lots of little boxes by the looks of it. I think that'd be the best way I'd try to draw it.
So you mean a rectangle that's 4 by 3?
Yeah.
That's my 12. Yes, and then?
Then you've got like the boxes of the 3 by 10, and you've kind of got the 3 by 8. So you could either do separate boxes, or if you took that original rectangle that you've done for the other ones, the 18 by the 12, and you just break it up. Yeah.
All right, I'm going to try that because I think for students it's really important to see how it connects to the original question. So 18 by 12, and then breaking it up into little subsets of that. Is that what you mean? But the problem is that the 4 times 3 that makes the 12 is all on the same line. So I can't do the little area model with 4 by 3 using this rectangle.
I think I would start with the brackets.
Yeah.
So you could draw 18, just change the 12 to a 3.
Okay, let's do that.
And break up the 18 into 10 and 3.
Okay. 10 and 8, yep.
Oh, sorry, 10 and 8, that's what I meant, sorry.
Yep,
10 and 8.
Yep, 10 and 8.
And so inside you'll have your, yep, that's right. And then I would draw 4 lots of those.
Oh, that's right. So then 4 lots of those. Yeah, that makes sense. That's great. So we've got 3 here. We need 4 lots of them. Yeah.
Yep. So Daniela, what you can do is use the loop tool and circle the thing and then just copy paste, copy paste.
You know what? That's brilliant. I'm going to do that. Yep. Thank you. Loop tool. Wait, where?
Yeah, right here.
Stuck. Yep.
Above your name. Yep.
Yep. Okay. I'm going to thank you for that. That's wonderful.
Copy paste, copy paste, copy paste.
I should have shrunk them before I copied them. There we go. We got 4 lots of them, and then that's overlapping. And then you simply get the 54 and you quadruple it. Yeah, brilliant. Thanks so much. I appreciate that. Sometimes in the heat of the moment, I can't think, so that's great. All right, and wouldn't it be wonderful if a student actually was able to tell me to do 4 lots of those rectangles like that? That would be showing me a lot of understanding about multiplicative thinking and everything like that. Okay, so we'll stop with these kind of multiplication questions now, but we'd like some, if anyone wants to contribute any insights or how they found that experience. If you want to ask questions, please use the next couple of minutes to do so, either via chat or unmute your mics and just have a chat with us.
Hello?
Hello?
Yep.
Yeah, I love using the area model, not only for this type of multiplication, but also for fractions, and then even extends into early algebra. So I love using this visual approach, area models. Yeah.
That's right, and that's right. It's really powerful with algebra as well, because all of a sudden expanding brackets becomes a lot more conceptual. So that's wonderful.
Yeah. It's a great introduction to algebra, and as you said, drawing can be hard, but is very useful, as Tamara said, and it's obviously usually a lot easier if you stay in front of a whiteboard than trying to do it in this format as well. So which Danielle has done a great job of anyway. So yep. Any other comments? And can we ask you, as you unmute yourself to share something, can you just give us your first name so we know who's talking to us? It'd be nice.
Anyone actually tried these number talks with their students before, this kind of thing? Hong says yes. Yes, Tamara too. That's great. Good to see that they're kind of getting out there. Oh, all the time, Lauren. That's great.
Oh, well, some of those people that have has anyone actually tried it? Okay, simple with grade 1. Okay, how many people have actually tried it with, say, year 7s or early secondary? Just interested to see how that's gone.
Hi, it's Michelle.
Yeah, Michelle.
I'm just about, well, I was just about to before we went into remote learning, so just with year 7s.
Mm-hmm.
So we're kind of dabbling in it through OneNote, which is not ideal, but yeah, just started.
Yeah, like you said, you've seen me use OneNote now, and I've got a tablet that I can't see what I'm drawing on the tablet. I have to look up and draw down, which is kind of, that's why my writing ends up being a bit messy. But if you've got a laptop that can be converted into a tablet and you can look at what you're drawing and you can use OneNote, it's still pretty effective. I mean, it's never going to be the same. Maths classes won't ever be the same in the virtual world, but it's still quite effective, as you've probably seen us do now. So
yeah, and it was very interesting to find. Sorry, we started off with addition, and some of the students had no strategies other than that vertical algorithm, even though I said, please don't use it.
Right. Yeah. So they've been conditioned so much to use it that they've forgotten what addition even looks like mentally. Yeah. It's a bit of a shame.
Thank you. We've got some great contributions here. So we've got Bow's use of a 7 and 8. Good luck to Tamara, who's doing it as a VIT project this year. That'll be interesting. Hopefully you'll be back online before you get to present your VIT project in person. Savita, great. Year 8 and Year 11. Oh, I'd be interested. Savita, do you want to share how you've used it with Year 11?
Yeah, with this year, it's the same actually, teaching them the concept of basic multiplications and making how it's been used here, I think so. Sometimes it's an awe moment for the year 11s as well, when they try and solve these questions, how they are. And misconceptions is what are really cleared through this, I think. So that's what I found useful using number talks.
Absolutely.
Yep, terrific.
And I've actually cleared some misconception in adults with multiplication recently as well, which is so yes, year 11s. It's applicable across the board. Okay, maybe we, Helen, we move on to
I'll
the
move on
fraction
to the next
talks
one.
now.
Okay.
So I'll let you
Right,
share your
so
screen.
I'll share mine now. And yeah, just while we're doing that, yep, great. Yep, using whiteboard and WebEx, yep. And the algebra, it's great for algebra, and the visual is really important. So yep, thank you for those. Okay, back to sharing my screen. Here we go. All right. So now we're going to move away. Okay. All right, so similar idea. This time we've got fraction talk. So as I think someone said earlier that they've done it, but mainly started with addition. So because we knew that a lot of our audience was secondary, we thought we'd start with multiplication. And because often in moving from primary to secondary, one of the key difficulties that students have had, or a little block, is they haven't moved from additive to multiplicative thinking. So that was our idea for starting with multiplication as well. But they can be used, I will leave this one, that one we did, and there's one that you can take away and have a go at as well. But you'll get access to the PowerPoint as well as to the recording. Okay, so here's, we're going to be looking at a couple of fraction talks that can be used with pictures. So if this one, I'd like you to record in the chat box what fraction of the whole is purple. I want to see how quickly we can do that.
Okay, lots of people saying a half, Helen.
Okay, and those that have said a half, does anyone want to suggest how you came to a half? So, yep, please unmute and let me know how you got the half. What was your strategy?
Hello, it's Julianne here.
Yeah, hi, Julianne.
Hi. I counted the purple triangles, and then obviously I put the two triangles together to make a hole and looked at how many holes I made, and overall looked at how many squares they were, and so I realised it was half.
Yep, terrific. Okay, did anyone
so
have...
when you say whole, you put them together to make squares.
Squares,
Put the
yes,
triangles together
what
to
you're
make
saying.
squares, and then you counted how many squares were in total. So you knew there were 6 squares in total, and you made 3 squares. So that means 3 out of 6 is a half.
Correct.
We've got a few people as well. I might just share what's happening in the chat box, Helen, suggesting that they counted the triangles and worked out it was 6 purple triangles out of a total of 12 triangles. So 6 out of 12 is a half. All right, wonderful. And can we move on to the next problem?
Yeah, so I've just got a few more questions with these, so I'm just going to pass through. So you can actually change. So one of the ways is to give a particular colour. Another one is, what about if I asked you for what colour represents exactly 1/3? And if I then said the purple is worth 1 whole, how much would the blue be? So that's just presenting the question a different way. Or if I told you that the total area of the shape was 5, what area would the red represent? I might just give you 2 minutes to choose one of those 3 and see if you could give me a solution to one of those, or your solution. Blue is 1/3, someone said, if I had asked for what colour represents 1/3, yeah? So if I did say purple was worth 1, how much would the blue be worth?
So now changing what our whole is defined as, which is something that we can do with any of these. We can say that red is 1. We can say that, a red and a +1 purple triangle is 1. So,
Okay. Thank you.
Alice.
So I'm looking at the answers. Yep, we've got.
Hello, yes.
Hi, is that Alice?
Yes, it's Alice.
So explain to us, please, how you worked out if the purple section was 1 whole, how much would the blue be?
So if the purple was one whole, I imagine that obviously there's 3 triangles worth of purple. So I imagine that it was cut into 6, and the blue is of equal size to the same size of the purple triangles, and there are 4 of those. So like if I rearrange them on top of each other, it would cover 2/3 of the shape.
Okay, so what I'm hearing is that you said that the purples were 6s. Is that right?
Yes.
The
So
purple was 6, yep.
yeah, so the purples, I imagine that like the triangles represented 1/6, like one purple piece represented 1/6. Yeah. And the blues, obviously there's 6 of those and there's 4 of the blue.
So 4 out of 6 is 2 out of 3.
3.
Yes.
Thank you. All right. And Alice, that was the one with the purple as well. Okay, Josh is saying could use ratios. Yep, there is another way of doing it there. Hong, the 12 triangles, 4 of the same colour would be 1/3. In the question was how much would 1/3? And you could see we've just used these as the typical type of question we'd start with is what fraction of the choose a colour and say what fraction does that represent. But then the rest of the questions we've just made up, and you can vary that. You can choose any number to be the whole, or you can choose the total to be any size. It doesn't have to be. And that gets kids away from thinking that the whole picture as we see it is the one whole. You know, if we said, well, the whole lot is worth 5 or 10 or 20, does that make it? Okay, here's what we're going to do one more with the picture and just take it a little bit, makes it a little bit hard. They're not all exactly the same size as in the triangles this time. So with this one here.
Helen, just wait. We've got Jason asking a question about the previous one. Is it possible we address that first? Jason said, is 10/12 the value for red when the whole area is 5? So let's have a look. How many triangles do we have all together? Well, there's 12, and we've got 2 red pieces, so 2/12 of 5, which is 10/12. Yes, so you do a bit of a fraction multiplication. So talk about what 2/12 or 1/6 of 5 would be. So it would be 10/12 or 5/6.
Yep, as Catherine said. Yep, terrific. Okay, yep, sorry. So, yeah, you monitor the chat while I'm going.
Yes, I'm doing that.
We're both keeping. Thank you. All right, so here's the next one for us. A little bit more challenging because they're not all equal in that regard. So this time round, what fraction is represented by red? So we'll give you a couple of minutes to type in what fraction is red in this one. Okay, I'm seeing a couple of 1/3 there, Daniela.
Yep.
Okay, maybe we might just get one person, if they don't mind just sharing how you said that was 1/3.
Anna Watson.
Yeah, hi Anna.
Hi, I repositioned the 2 smaller reds to the other region. So I've got one whole block, which is red and, of the 3 major regions.
Okay, yeah.
Yep, so you've moved this small red over to here. So it took that bit and that one, but you've probably flipped it as well. Is that right?
Yeah, I flipped it around, made it 1, and then
So then it took up this whole section here.
Correct. And that's right.
Okay. Helen, maybe the rest of the questions, would just share them, possible questions you could ask rather than actually getting contributions.
We'll do that. Yep. Okay, so we just do that one slightly different. And these are some other questions we've come up with this one. So we could ask, can you find a section with half of that area? Can you find all the sections that would represent 1/6? And you could, use different combinations of colours there. Or what possible fractions represented by the diagram? So you could get them to list, and they could be quite endless, really. Or can you add a single line to make one section worth 1/24? So they're just some sample questions. Again, we can go with the one that if the area of one small red triangle this time was worth 1, what will be the entire section of the blue? So they're
So
just
here, yeah, some sample questions, just to expand the possibilities of what you can ask if you just present a little picture like this. There are so many questions you could ask that of it that it's quite very open-ended, and it can become very rich.
Yeah, and it makes it quite rich, and also this is starting to then build up and just make it quite open for some of you more able students as well, because we're trying to get a bit more challenging as we go. Okay, here's a slightly different one this time. If what fraction of the entire, oh, hang on, does each, yep, so here's one question. Basically, if we're looking at the coloured sections, rather than go with the whole lot, might just say if you chose 2 different colours, and you can let us know which one. So if you chose pink and the light green, for example, if you went B and C, what fraction of the entire rectangle to 2 sections? And then, of course, the way we'd normally give this is to ask you to then take every single letter and tell us what fraction of the whole that represented. So that one gets a little bit more challenging. So I might just get you to choose one particular section, the red, let's say F is red, and E or I and J, whatever you want, and let me know in chat what fraction that represents of the whole.
So Julianne said B and C together are a quarter, but Julianne, can you separate B and C and make them what B is and what C is? What Helen was meaning is choose 2 and work out 2 individual ones. So we've got a few answers coming through, Helen.
Yep.
We've got that's C's 3/16, B 1/16. We've got some 16ths, we've got some 8ths, we've got 16ths again.
Okay. Okay, so you can see that this one would take quite a while by the time you've gone through every single one. And we've got quite a few questions coming up with this one as well. So we've now moved this and said, okay, if we told you that C was worth the whole, so C was 1, what fraction would the other shapes make?
Yeah. I might just ask you all, if you're choosing 2 coloured sections to try to work out the fraction, how about you challenge yourselves and choose G? I think everyone's avoiding G, but if you want to have a bit of a challenge, go for G.
Okay, someone who we got here, Bow's gone A, B, C, D, E, and F. We will give you the slides, and then you can actually have a go at doing all of them as well. Okay. We've got a solution.
I'm sure about. I would love to see your solution.
Would you like to share how you got G?
Sure. For G, you can see no matter it's divided by diagonally or like a DHG or divided by horizontally like DC. Basically, it's symmetrical. So for we can split it into the whole rectangle into 4 rectangles. So in the top in the bottom left corner, we just split into like diagonally, like into equal pieces, like 8 pieces. So G takes 3 pieces like that, and D takes 2 pieces, H takes 1. So that'll be, but because it's the entire rectangle represent one fourth. So it's like actually it should be 3 out of 32, isn't it?
I think that you just made a simple error.
Yeah.
So what I'm hearing is that you have
3 out of 32. Yeah.
You've divided G up into sections that look like H. Is that correct? So if you look at H and you kind of reflect H or flip it, then you can have 3 H's within G.
Yes, exactly. Yeah.
You can have 3 H's within G, and H is then a quarter of that rectangle where G and H are part of.
And they were a quarter of, well, that section there.
Yeah, so that's 3/4 of that little section, which is a part of which is an eighth of the whole thing. So 3/4 of 1/8, which is 332. There's lots of ways of doing this, but that is a good one. Thank you. All right.
Okay, I just move over to a couple of other questions you could use, and we won't go through these ones because I'm just looking at our time. So yeah, key part with any of these fraction talks is to get students to explain their thinking, and then also to see if there's another way of explaining. So we saw that Bao was saying, okay, if I divide that, 3 H's will fit into G. G makes a quarter of this side, which is an eighth, etc.
And I just might interrupt. Sorry, Helen, there, and just that this one would also be one better to draw on and explain your strategy pictorially. I mean, using a whiteboard or whatever. What we should have done maybe is copied it over into OneNote and scribbled all over it to explain Bao's strategy. But we're running out of time, so we skipped that part. But just so you know, that's probably a much more effective way to share strategies.
And also with students, it probably would have given this as a handout as well, would be another way to actually, so they could actually draw on and explain it that way as well. Okay, this one we won't go through these, but you can also do it in the number form. So we had the picture fractions, but numerical fractions.
This one, what we're trying to obtain is the answer greater or less than 1? So it's not even a solve. It's just asking students to think about their division, because oftentimes what happens when they're doing fractions is that the students say, oh my gosh, we're doing fractions, and their brain just goes into some sort of panic, and they have to remember all the fraction laws, and they forget what's actually happening. So this is a division, and 1/3 divided by 7/8, and we're just simply asking them to consider if the answer would be greater or less than 1. And then we can discuss what the division means even. So lots of people saying less than 1. Yeah, so that's the point. That's a point, to discuss what's happening here. And to get them estimating, because estimation is vital in mathematics and we do it so little. So that's what this one is. Thanks for your contribution. So we'll move on to the next one, Helen.
Yep, so this is where we started with the warm-up. So it's another one to just think about, and maybe this one we might talk you through, and then we'll move on to the next one. We won't do the next one. So with this one, have a go at typing in which one, and then we might just get a couple of people to share solutions with that one or share their reasons why. So as you type in your response, maybe alongside of it, just put yes if you're happy to share.
So we have which one's larger, 8/9 or 10/11?
Okay, and we've got both answers are coming up. So
all right, Lauren's saying I still need to draw fractions to compare. So Lauren, I'd be curious to hear from you how you would be able to ascertain from drawing which one was larger. What would be your strategy?
In this case, because drawing 9ths and 11ths is kind of hard, I would probably pull up like a fraction wall or Visnos or something and do it that way.
Okay. Yeah. That's what I'm thinking. I was like, how would you draw 9ths and 11ths in any kind of accurate way? All right. Thank you. Let's see what other contributions we have. You have to make them to the same denominator so you can compare them. Okay, so that's a similar strategy to the person that Renee who said cross multiply. So that was Tamara who said that they made them the same denominator. Anna, it's interesting. Gap residual thinking. Can you explain that verbally to us, please, Anna?
Yes. If you think of the whole, one whole, and then think about the size of the parts, 1/11 is smaller than 1/9. So sorry, I didn't type exactly correctly, but yeah, your one part of 11th from the whole is smaller than 1 part out of 9, and therefore you're closer to 1.
Yeah, thank you. That makes so much sense. And Lindy, you also said the very same strategy, Lindy, so thank you for that. So yeah, considering the part that's missing rather than the part that we have. So the part that's missing from the whole, the 1/11th, is actually a smaller part that's missing than the 1/9th. Yeah, that makes sense. Thank you, Anna, and thank you all the others as well for your contributions.
Thank you.
We've got some fraction questions here. The first one was simply, is the answer going to be greater or less than 1? This one is comparing the size of two fractions. The next one we have for you, Helen, if you just move across, is actually solving. So it's getting a little bit more complex. We're not going to do this as a number talk because we're running out of time. It's already 4:50. But we just want to show what kind of problems you could pose to your students, and it's really quite differentiable. I mean, it's easy to differentiate. So maybe for some of your more advanced students, you could actually ask them to solve this without pen or paper. Whereas some of your weaker students, you might just get them to compare or tell you if the answer is going to be greater or less than 1.
And again, the richness is with that sharing when students actually, because by doing that and by listening to others, we all sort of gain and realise there's more than one way of doing it, but also it allows the other students to think through how they would do it and maybe come up with a different strategy.
Lots of people answering to that one already, so 3/2, that's great. Okay, so now we just thought we'd sum up. So what you've seen are 3 different types of number talks, essentially, a multiplication one. We've used fraction talks with pictures, and then we've done fraction talks without pictures. And so we just wanted to summarise kind of the benefits of number talks and get you sharing as well what you think the benefits are. So obviously they do help students strengthen their own fluency and mental strategies. So the more that they get exposed to doing things mentally, the more that they become fluent, and the more that they practice the mental strategies required, so they become more fluent. And then they start to have intuition, which is really important when we're dealing with numbers, that they have an intuitive sense of what the answer may be. The communication.
And we also find that often when people talk about that, they'll say that, oh, I can't move further with my kids because they don't have, I really want to focus on fluency. And so by fluency, they just tend to give them worksheets or lots and lots of the same problem over again and thinking that will gain fluency. But sometimes through the number talk and having the mental strategies, by sharing lots of different mental strategies, then students are indirectly building on their fluency that way as well. So it's and that communication really helps. Okay, we have shown you visual aspects, so it is visual, and we've said a lot of the problems were open, so there was different ways.
So especially in terms of the visual, in the first one when we did multiplication, I tried to not only represent your strategies in a number sense, in a number way, like a number numerically, sorry. But I also did it visually with an area model, just so that they can kind of connect the two, because those connections are really important in mathematics.
And as a lot of people said, that was really rich in leading on to the area model, algebra. A lot of you already went indirectly into, you went directly into distributive law, but for kids, that could be a way of leading into teaching that as well.
Anyone else want to share some benefits of number talks, what you may have thought today during this session, or what you may have experienced in your own classes while doing them? Feel free to unmute if you want to contribute at this point.
Hello, Anna again. Just challenges the kids to find alternate ways to solve, makes it more fun, more avenues in for other people that might see it different ways. It just adds more variety too, and it highlights that maths can be done in more than one way, which is good for self-esteem, right? Because people might have intuition and they think it's not valuable, but it is quite valuable.
And how important is it for the teachers as well to realise how valuable it is to expose students to multiple strategies? Because I still remember to this day when I was at school that I always had strange ways, according to my teachers, of solving problems. And I had one teacher in year 8, I think it was, who used to actually tell me off for that. He used to say, Daniela, I know you're getting the right answer. I know your strategy is probably legitimate, but it's different to the strategy I taught in class. So can you please stick to my strategy? And I didn't like that at all because he was limiting me in my creativity. So it would be it's really important to show the students that we value this kind of variations and different strategies that students come up with.
And there are lots of strategies. Okay, and there was a couple of questions here. What do we do with students who don't know the number facts? As we said, I think people have responded to that. So there's a couple of different ones. You can start as simple as you like. Listening to others share is also good. And the other one is, normally if I would do this, once we did a few multiplication ones, I'd actually teach them some estimation skills and then go back and revisit. And then you can actually throw some harder ones. So like, we talk about things like rounding, etc. Some of those strategies that we automatically did, you can actually teach some of those mental strategies. And those of you who've heard us do the workshop on multiplicative thinking, again, there's the strategies within the times tables that Di Seaman refers to. So teaching students a lot of those sort of strategies and then revisiting more challenging number talks is also good. Okay, and here's a few of our tips. So we'd say like with warm-ups where we tend to spend 10 minutes or so with a warm-up, maybe just make them a regular part of your class when you're doing this and keep it short, 15 minutes. So you sort of give them 1 or 2, have students do it, have 2 or 3 that you share, etc. And make sure, just in answer again, reiterating what we said earlier, start with a problem that's accessible to all. So I think you would have noticed that we went single digit by double digit, then we moved to double digit by double digit, and then we went to fractions. So, and even with your fractions, you can start with simple. You might be comparing, a half to a third or something that's simpler first. Keeping the environment safe and positive. So as we said, the thumbs up rather than the hands up, or in the virtual medium. And someone did say we should have used some sort of emoji in that. We should have could have done that with WebEx as well. We're also going to, when we send off the email, we'll also email you a document that was created by one of our colleagues with tips on number talks as well.
So yeah, just to reiterate what Helen was saying, you'll get that document, which is a document about tips and talks, but you'll also get this PowerPoint, and this session was also recorded, so you'll get that as well if you ever want to revisit that. Here's a survey link that we'd really, really appreciate your feedback for today's session. We really look carefully at our feedback and we make sure that we take it all on board for next time. So anything that you can add to that would be fantastic for us. So please take a few moments now, if possible, to do that.
Daniela, can I ask you, while I've got my screen here, could you copy that into the chat box?
Sure, I'll copy the link box so that people can just... Yep, no problem.
Okay, so while Daniela's got that, so people can access the survey on there. So we, as I said, we appreciate you taking a few minutes to do that. And those of you who have done that or are doing that at the moment, we're going to leave you with one to think about, to take with you. So there's one for those that aren't doing their chat box. There's a little takeaway challenge for you to think. So we look, what fraction of that is actually shaded?
This might be for some of your VC students even.
So again, there's that thing about these can go as easy as hard as you. And again, lots of different, we'll also provide you some resources where you can get these. We said there was the tip sheet we'll give you. There's a paper by Dan Finkel. We'll give you the link to Joe Bowler's YouTube channel with lots of number talk. Or there's also got, there is a video clip there with Kath Humphreys actually talking through it with a group of student teachers and talking them through, pre-service teachers, I should say.
And the book that was, the book that was suggested, which is Making Number Talks Matter, is a fantastic resource. Yep. I can't recommend it enough. There's reading through it. There's plenty of really practical examples that you can give to your students and examples of student solutions and how you might talk through that. So I'm just going to write the name of the book into the chat box. So it's called Making Number Talks Matter. Okay, I'll just put that in.
Yep,
I'm going to
okay.
see if I can.
I'll
Looks
just
like
hold that up to someone who said they wanted to see that, but it is available from MAV shop. So yep, if you look at that there. And the great thing with this, as we said, Ruth Parker and Kathy Humphries first came up with it, and then it was the other Kathy that then has added to this with I've gone blank with my names now. Who's added the secondary component to this. So as you see, this is now applicable to years 4 to 10. So it's the one that's got the secondary applications as well.
I've also just shared the link to the MAV shop Making Number Talks Matter book, so you can actually see it all on there. Someone's asked, what's the answer, please, to this one, the pink one? We don't know. Well, we might know, but we won't tell you because that would be just stealing it from you.
And look, it's another way. Like I often used, I'll not always use warm-ups at the beginning of the lesson, but sometimes it's a little bit of a different strategy. If you've got a shorter lesson, you may not start with one. You may actually finish your lesson with a bit of an activity and leave it as a take-home task for kids. And the next morning or the next beginning of the next lesson, then revisit it and say, okay, you've had a bit of time. Because that, and sometimes even if you've had a few lessons in between, some of those kids will go away and we'll spend a couple of days trying to make sure they do solve that. So the book we've got there with the full title, sorry about that. The Maths for Love has got some of those, that was good for the picture ones. A lot of those fraction pictures we got from the Maths for Love site, the images, sorry there. The YouTube clip has got the actual presentation where you can actually watch a video. And we've got the paper that will give you, that gives lots of tips and ideas, and then our own MAV, as we said, put together by one of our colleagues. So
plenty of resources there. Fraction Talks Images, that website is full of just images that you can just take and run with. Now, I would suggest maybe starting your classes with a number talk to warm up the, the brains. It's like a warm up. So, all right, thank you, everyone.
Thank you for
your contributions. You've been fantastic today, and thanks also those who have taken some time to fill out the survey. We appreciate it.
And likewise, thank you for me as well, and thank you for being so great in being willing to share and also put yourself out to share your contributions verbally as well. So terrific.
Okay, I might stop recording now.